Hi dear all, welcome you all to Brilliant Group of Institution. Here we are going to discuss JEE Main Previous Year questions from the chapter Haloalkanes and Haloarenes, the organic one. Dear all, let's go to the first question from 2004. The compound formed on heating chlorobenzene with chloral in the presence of concentrated sulfuric acid is. A simple question from the area polyhalogen compounds. You may study the freon and chloroform, iodoform and DDT, etc. Right? So the compound formed on heating chlorobenzene. The reaction, let me tell you dear all. You may study that. Let me consider two chlorobenzenes here. Just we can write the reaction in a simple way. These are two chlorobenzene. And let me consider what is chloral. What is chloral? What is chloral means dear all? Chloral means CCl3 with CHO. CCl3CHO is called chloral. What is another name of chloral dear all? It's having two carbon in the parent chain, right? Two carbon in the parent chain. And it's an aldehyde. CHO group is there, so it's an al. And it's having 3 chlorine, 2 carbon aldehyde. So it's called trichloroethanol. Trichloroethanol is also called what? Chloral. So what's the reaction when they treated with H2SO4 on heating dear all? Just we can do the process just like a dehydration. Take one H from this para positions and this HHO, that's H2O that you remove, just the remaining one just join together. You will get the products as dear all. This is the chlorobenzene part. Is the chlorobenzene part, yes, and these are connected to what? This carbon on which one hydrogen already there and CCl3. This is the compound called DDT. What is the full form of DDT dear all? DDT stands for diphenyl trichloroethane. Diphenyl trichloroethane, that's what we call DDT. So what is the answer dear all? When chlorobenzene react with the chloral, the compound is what? DDT. Option D is the correct answer. Let's go to the next one. Alkyl halides. What is alkyl halide? RX, right? RX. When react with the dialkyl copper reagent, which is the one of the dialkyl copper reagent dear all, that is what? Gilman reagent. Gilman's reagent. Dialkyl copper. Let me tell you what is Gilman reagent. R2CuLi. R2CuLi. Dialkyl copper with lithium. So what is happened when haloalkane react with a dialkyl copper, the lithium, that's Gilman reagent dear all? You will get the product as RR plus RCU with LIX. This is the byproducts. So what's the product RR dear all? It's an alkane. So answer is what? Alkane, option C. So dear all, when an alkyl halides, haloalkanes, when react with a Gilman reagent, what is Gilman reagent? Dialkyl copper. When react with, you will get alkane as a product. So question number 2, that's from 2005. Dear all, option is C. Let's go to the next question from 2007. Which of the following is the correct order of decreasing SN2 reactivity? You know, SN2 reactivity, the correct order of their reactivity is what? Primary greater than, secondary greater than, tertiary for the haloalkanes, right? Lesser the steric hindrance, more reactivity. So let's consider the reactants given here. RCH2X is given. And second one is given R2CH. What do you mean by R2CH dear all? R2CHX. And next one R3CX. Right? These are the compounds given. You can able to see very simple dear all. Which is a primary one? It's primary, right? It's a primary haloalkane. It's a secondary haloalkane because the halogen connected carbon directly connected to 2 carbon. This is secondary. What about this one? Tertiary. Which is more reactive? This is more reactive and least reactive. The last one. Lesser the steric hindrance. Yes, you can able to see here more steric bulky groups are there. More the steric hindrance, less reactivity for SN1 mechanism. Sorry, SN2 mechanism. Therefore, for SN2 mechanism, we are checking the steric hindrance as a factor. Lesser the steric hindrance, more reactivity. Whereas in SN1 mechanism, we are checking the stability of carbocation, which is more stable carbocation form, whereas more reaction happen, right? So here, less steric hindrance, more reaction. So what is the option, dear all? Option B, RCH2X is more because it's primary. R3CX is least because it is tertiary. Clear, dear all? Next question. Question number 2008. The organic chloro compound which shows complete stereochemical inversion during SN2. Dear all, you know SN1 mechanism, if there is a substance undergo SN1 mechanism, there will be a retention of configuration, whereas in SN2 mechanism, there is an inversion of configuration. They're asking you where you will get complete inversion, which will undergo SN2 reaction faster. That's a question. Which will undergo SN2 reaction faster, dear all? We can able to see which is a less steric crowded part, dear all. That's D is the haloalkane. Where steric hindrance, where bulky groups are too small, too less, there more reaction can happen through SN2 mechanism. Option D is the answer because there is less steric hindrance, right? Next one. Phenol is heated with a solution of mixture of KBr and KBrO3. The major product obtained in the reaction is question number, it's from 2011, dear all. Phenol when react with a mixture of what? Solution with a solution of mixture of KBr and KBrO3. Dear all, when KBr react with the KBrO3 solution, which means water, what we will get first? KBr when react with the KBrO3 along with the water, first we will get Br2 along with the KOH. What is Br2, dear all? You know bromine is a production of bromine actually. You know bromine water is a very strong brominating agent, right? So where we are adding this one on phenol, you know very well phenol is a very strong ortho-para directing group, yes or no? Phenol is a very strong ortho-para directing group to which when you add bromine, dear all, what happened? All the ortho and para positions are occupied by bromine electrophile. You know it's an electrophilic substitution reaction. So Br and Br, you will get the product as 2,4,6 tribromophenol. What is our answer, dear all? That is option B, 2,4,6 tribromophenol. So first of all, dear all, when KBr react with KBrO3 along with the water, it will form bromine along with KOH. This bromine, when you add on phenol, you will get all the ortho and para positions occupied by bromine. You will get 2,4,6 tribromophenol. It's an electrophilic substitution on phenol. Right. Next one. Question number, this from 2012. Which branched chain isomer of the hydrocarbon with the molecular formula 72U gives only one isomer of mono-substituted alkyl halide? You know, these are hydrocarbons given that you directly studied from the chapter Haloalkanes and Haloarenes. I think the question will be like this one. Among the isomers of pentane, which will give only monochlorinated products? You know, that's what neopentane. What is neopentane? CH3, CCH3, CH3, again one more CH3. This is called what? Neopentane or 2,2-dimethyl propane. You know, to which when you add chlorine in presence of light, you know, substitution happen in presence of light or heat. What happened here all? You see all the CH3 are same type. If you remove hydrogen from any of the CH3, you will get the same product. Suppose I am removing hydrogen from this one and I am adding chlorine here. I will get the product as CH2Cl, C, CH3, CH3, CH3 is the product. If you remove hydrogen from this, you will get the same product. If you remove hydrogen from these two, you will get the same product. So dear all, neopentane on substitution reaction, you will get only one monochlorinated product because all the CH3 are identical type. Next question from 2015, dear all, let's go. The synthesis of alkyl fluoride. What is alkyl fluoride? For example, RF, right? Alkyl fluoride, let us consider RF. The alkyl fluoride is best accomplished by which of the following reaction from which you can prepare an alkyl fluoride with a pure one? Dear all, Sandmeyer reaction, we can cut it. Because Sandmeyer reaction, you know, it's a conversion of benzene diazonium chloride to chlorobenzene and bromobenzene, either, you know, by using CuCl with HCl or CuBr or with the HBr. Now, Finkelstein reaction we can cut. Finkelstein reaction we use to get what? Alkyl iodide by using sodium iodide and diacetone. It's an halogen exchanging reaction. Dear all, either it can be a free radical fluorination or Schwarz reaction. You know what is Schwarz reaction? Schwarz reaction in which, for example, let me consider RBr. When I treated with AgF, for example, let me consider one compound CH3Cl. I have methyl chloride. When we treated with the AgF, what happened? AgCl eliminate, you will get CH3F, right? AgCl along with CH3, AgCl along with CH3F. This is one of the best method to prepare alkyl fluoride Schwarz reaction. Then why free radical fluorination is not possible? Dear all, free radical fluorination is a little explosive reaction. Free radical fluorination is an explosive reaction, so it is not suitable method. And let me tell you one more advantage of this Schwarz reaction. The produced AgCl is a white colored, it's a solid compound. It will deposit as a precipitate. So it's easy to separate. You will get pure alkyl fluoride through which reaction? Schwarz reaction. Option D is the correct answer. Next one. The major product of the following reaction is, what is the reaction given here? There is a cyclohexane given with two methyl group on the same carbon, and there is a solid wedge is given on which Br is there. What is the meaning of the solid wedge, dear all? This bromine is projected towards you. It's a three-dimensional structure, right? And when it is treated with what they are treating, dear all? NaOMe. What is NaOMe? Sodium methoxide. Sodium methoxide, where you can see Na plus OMe minus is there. Dear all, it's treated with what? MEOH in presence of methanol, right? Methanol is a polar protic solvent, you know, polar protic solvent. Dear all, what going to happen in this reaction? Dear all, OMe, methoxide, keep in mind all of you, methoxide is a strong base. Methoxide is a strong base and it's a haloalkane. Methoxide base with a haloalkane, it undergo beta elimination, right? When haloalkane react with a strong base, it undergo beta elimination. What is beta elimination? Dehydrohalogenation. So it undergo beta elimination. What do you mean by beta elimination? There is halogen you have to take from alpha carbon, hydrogen you have to take from beta carbon, and we have to make a double bond between alpha beta. What is the real mechanism about this one, dear all? So here on this carbon, this is the alpha carbon, right, where the halogens are connected. The beta carbon, on this carbon there is no hydrogen, so let's go to this carbon on which we can able to see there is two hydrogens are existing, right? Two hydrogens are existing, yes. So how we can replace the hydrogen? Here all, the base, the OMe, the base will abstract this, take this proton, and what happened? This bond electron shifted here, so it become double bond and the bromine leaves. Actually what we are doing here, we are taking halogen from alpha carbon, we are taking one hydrogen from beta carbon, and we are making a double bond between alpha beta carbon. So what is the product in this one, dear all? There is two methyl groups already here and one double bond here. You will get an alkene. You know, haloalkanes when undergo beta elimination, we will get alkene. So what is the answer, dear all? It's nothing but option A, right? It's, so remember, NaOMe, where OMe, methoxide, is a strong base. In presence of a strong base, haloalkane undergo beta elimination or dehydrohalogenation. Next one, question number, it is from 2017. Increasing order of reactivity of the following halide for SN1 reaction. Dear all, SN1 reaction reactivity order, if they're asking, you have to give more concentration on the stability of carbocation, which is the most stable carbocation. You check it where more reaction happen. Let me consider the first compound given as CH3 CHCl, then CH2 CH3. First compound is given. Second compound is given as propyl chloride CH3 CH2 CH2 Cl, and the third one is given as para position COCH3 and benzene ring. So C6H4 para position methoxy group is there, and here we have CH2Cl. These are the structures given, dear all. What is the first step in SN1 mechanism? In SN1 mechanism, first you remove the halogen, make a carbocation. Remove the halogen, make a carbocation. Now you identify what type of carbocation is this. What type of carbocation is this? It's pure secondary, because the carbocation connected to 2 carbon. It is secondary carbocation. What about this one? It's connected to 1 carbon. It's a primary carbocation. What about this one? They're all benzene with a carbon. Benzene with a carbon with a plus charge. It's called what? Benzyl carbocation. Benzyl carbocation, where there is a methoxy group. Dear all, methoxy group is a plus I group. Dear all, it's an electron donating group. It's a plus I group. Carbocation stability increased by electron donating group. If there is a plus I group, if there is an electron donating group, they will increase the stability of carbocation. Already benzyl carbocation is more stable. Already benzyl carbocation is more stable due to what? Resonance. So dear all, secondary, primary, benzyl, which is more stable one. Benzyl, right? So third one is greater stable or greater ready to undergo SN1 mechanism, then secondary, first one, then second one. So 3, 1, 2, 3, 1, 2, yes, option is B. Next one. Here we have a question: which of the following upon treatment with tert butoxide, with sodium tert? What is meant by this compound here? All sodium tert butoxide. Sodium tert butoxide. What is sodium tert butoxide? Is actually, this is tert butyl. This is tert butoxide with what? ONA. Sodium tert butoxide. So which of the following upon treatment with a sodium tert butoxide following addition of bromine water fails to decolorize the bromine? Let me do first of the reaction. Sodium tert butoxide, it's a basic one. Sodium tert butoxide, where tert butoxide is a basic part, dear all, it's a basic part. So in the presence of a base, haloalkanes undergo beta elimination. Let me do beta elimination first, dear all. What do you mean by beta elimination? Halogen you have to take from alpha. One of the hydrogen you have to take from beta, and you have to make a double bond between alpha beta. Yes, you'll get this product after removing bromine and H. Alright. So here there is a chance to get double bond. Alright. What about the second case, dear? In second case, option B, let me take halogen from alpha. Is there oxygen? So let me take one hydrogen from this one hydrogen from this beta. So I have to make a double bond where in between alpha beta. We'll get this product. We are getting an alkene. What about in this case, dear all? Let me take halogen from alpha. Let me take one hydrogen. Here there is no, on this carbon there is no hydrogen. So let me take one hydrogen from this beta, and I have to make a double bond in between this alpha beta. What about option D? Let me take halogen from this alpha. Is there any beta carbon, dear all? Is there any beta carbon on this group? Dear all, it's not oxygen. It's not which one carbon? It's an oxygen. So there is no hydrogen on this one, right? So here we cannot prepare a double bond. Yes or no? Dear all, the question: the haloalkanes already they treated with sodium tert butoxide. It's a base, so undergo beta elimination. That already we did, except D, because D option there is no alpha hydrogen to remove. Now, when they add bromine water to this compound, to an alkene, to an unsaturated compound, when you add bromine water, the reddish brown colored bromine water, it becomes decolorized, right? It becomes saturated compound. So here the question, where it fails, when you add bromine water to these 4 compounds after this reaction, after dehydrohalogenation, after beta elimination, where bromine water doesn't work. That where we can option that option D, because there is no double bond formation, right? All of the option A, B, C where double bonds are forming, so it react with the bromine water, it become decolorized. Where it fails to react with the bromine water, that is only in option D, because there is no dehydrohalogenation, right? Option D is the answer. Next one, the major product obtained in the following reaction is, dear all, again what is given here? Potassium tertibutoxide is given where K plus and TBuO minus. It's a base. Potassium tertibutoxide is given, and on heating means what? What's the reaction? Again dehydrohalogenation or beta elimination. Dear all, sodium methoxide, sodium tertibutoxide, these all are what? Bases. So beta elimination happen for a haloalkane. What is beta elimination? Halogen go from alpha, hydrogen go from beta. So let me consider the hydrogen from this area. Let me consider there are 2 hydrogens, right? There are 2 hydrogen in this area. So how to remove this hydrogen, dear all? Tertibutoxide, the base that will attract is H plus, that will take the proton and this double bond. Where this double bond shift, dear all the new bonds formed, dear all, it will form this side more, you know, according to Zaitsev rule, more substituted alkene should form. So maximum try to make the double bond almost in a more congested area. So where the, what is Zaitsev rule says there? More substituted alkenes are more stable. So the tertibutoxide taking the proton and this electrons leaves and form a double bond, and the bromine release. So what is actually the process, dear all? Halogen we are taking from alpha carbon, hydrogen we are taking from beta carbon, and we are making a double bond between alpha beta. Product is C6H5 single bond CH double bond CH single bond C6H5. So is there any answer, dear all? Please check it, all of you. Is there any answer, dear all? C6H5 CH double bond CH C6H5, that's nothing but beta elimination in presence of a base, right? That's it. Next one, 2016, 2-chloro-2-methyl pentane. What is 2-chloro-2-methyl pentane? 2-chloro-2-methyl pentane on reaction with sodium methoxide, right? Sodium methoxide. What is sodium methoxide? NaOCH3. Sodium methoxide in methanol yields. What's the process, dear all? Very careful, dear all, in this question. They didn't ask you which is the major product. If these 2 reactants given, what all products can form? That's a question, right? It's actually, it's a haloalkane, right? Is it a haloalkane? Yes. Is it a sodium alkoxide? Yes. When a haloalkane react with sodium alkoxide, there is a chance to get what? Ether, that is through our Williamson ether synthesis. So let me remove this Na and Cl, the OCH3 we can attack here. So we will get CH3, COCH3, and one CH3. We have CH2, CH2, CH3. It is one of the product can be expected. So that is this product is there? Yes, CH3, CH2, CH2, C, CH3, CH3, OCH3. Option A can be possible because Williamson synthesis can happen when a haloalkane react with sodium alkoxide. What about option B and C? Is it possible or not? Yes, dear all. Why? Sodium methoxide, as I told you, methoxide is a strong base. Methoxide is a strong base. In presence of a strong base, haloalkane prefer to undergo beta elimination more. So this presence of OCH3, what is beta elimination? Halogen go from alpha, hydrogen go from beta. You can take hydrogen from either this beta or this beta. These two are actually same, right? You can take hydrogen from this beta or this beta. Let me consider this beta. Let me write beta 1. This is beta 2. Just for understanding, okay? So what is beta elimination, dear all? Halogen you take from alpha. One hydrogen you have to take from beta. So any of the beta we can select. You will get 2 products, right? So if you're taking hydrogen from this beta, the double bond come this side. You will get the product as CH2 double bond CCH3, then CH2 CH2 CH3. You will get this product, dear all. Plus If you take hydrogen from this beta, I have to make double bond here. So I will get one another product as CH3C CH3 double bond CH single bond CH2 CH3. So dear all, is these two products are there or not? Please check it, all of you. Is these two products are there? Yes dear all of these A, B, C, all of these can form. Option D can be the answer. Why dear all? When a haloalkane react with the sodium alkoxide, it can undergo Williamson synthesis. If the sodium alkoxide parts contain a strong basic part, haloalkane prefer to undergo beta elimination also. In beta elimination, there is a chance to get what? Major and minor products, right? Alright. Next one. In SN2 reaction, what is the correct order of the reactivity? SN2 reaction means dear all, question is from 2014. SN2, SN1, you can able to see it's a most repeated one. SN2 reaction, which is the most reactive one. SN2 mechanism, what is the factor we have to consider? Lesser the steric hindrance, lesser the bulky group, were more reaction. It's CH3Cl, CH3CH2Cl, CH3 twice CHCl, CH3 thrice CCl. So were more bulky groups in the last one. It's tertiary. Were least bulky group in the first one. More reactive. So first, second, third, fourth. The correct order dear all. CH3Cl is more reactive than CH3CH2Cl. Yes, that's option D. CH3Cl first because it's have only one bulky group. It's having two bulky group. So here having a tertiary, a secondary, and it is tertiary. What is the reactivity order of SN2 mechanism? Primary greater than, secondary greater than, tertiary. Alright. Hope you clear all these questions dear all. So let's meet again in another session for the same chapter, Haloalkanes and Haloarenes, the previous year JEE question. In the upcoming video, we can meet again. Thank you all. Bye.
Brilliant Qatar, your trusted coaching partner for IIT, JEE, NEET, Science and Commerce tuitions with 10 years of excellence in quality training. Brilliant Qatar.